So for the novices who are not necessarily picking up on what Ron and Fred are talking about, um, I have good friends that are pulmonologists, and he provided me with about 3/8 of an inch stack of 8.5 by 11 paper from a medical research facility that's available to that field, that identified the carcinogenic aspects of hardwood dust. So it scared the crap out of me. Um, and the contrast is well documented between hardwood dust and softwood dust. The particles are much finer with hardwood, and when you're sanding, they're smaller yet. So you should always wear dust, an N95 or better. The mask that Fred was showing offers a tighter seal than the paper N95s. It's invest in your future health. Lung cancer is not a good way to go.
Mm-hmm. Yeah, well, this is the N95 that Gene's talking about. Mm-hmm. The other thing I would mention along the lines of what Gene was talking about, especially for the people who are not familiar with the fact that spalted wood, you have to be very careful with it, because if the spores have not been killed, in other words, you find a spalted cherry tree out in your yard and you decide you're going to use it, those spores are more dangerous even than the dust.
That's good to know. Because I like spalted wood. I should tell
you. Yeah, but if you buy it from a supplier, no problem. But I learned about this many years ago when someone in Connecticut wrote an article about spalted wood, and it was posted posthumously because that's exactly what killed him. He had been doing it for 20 years, and the spores got into his lungs, and that was the end.
Interesting.
Yeah, so primarily, Fred, you're talking about the difference between air dried and kiln dried.
Yeah, I'm not sure about air dried. I'll tell you, my one experience that scared the heck out of me was I had a cherry tree. It was a beautiful Yoshina cherry tree with about a 12-inch thick base, and it started to get some sort of disease. So I put it, I cut it up, and I put a piece of it, in a trash plastic bag, a big black one. And I poured some beer in it, and I sealed it. And I kept it in my shop. And about a year or so later, I opened it, and sure enough, it had spalted. But because I knew about this through the article, I took it outside, left it through a winter to air dry, and that killed the spores.
So it isn't, it doesn't have to be kiln dried. It's just a matter of time and letting it.
Time and temperature.
Yeah, time, temperature, and moisture.
Right.
Right.
Exactly.
Gotcha. Yeah. Once that, I assume that as soon as that spalting mycelium runs out of food, it's probably just going to die from there, and moisture, you know, in that aspect of it. So
I'm actually going to argue with you on that. You're talking about fungus. Fungus is a family of a whole bunch of different animal species or living species, and the spores of mushrooms, fungus, yeast, et cetera, will survive a very wide range of temperatures, including freezing. So I'm going to do some research on that, and I'll find out. But as a beer brewer, I stored my yeast material in the freezer and of a refrigerator, you know, so it's down somewhere between 0 and 32. And the whole deal with spalted wood is you just lay it on the ground and cover it with leaves, and it will spalt. Now, the North American region, all the way up to Maine, gets well below freezing, well below zero in some cases, and we still get spalting, we still get fungus, and it continues to grow on the outside of trees. So I'm a little leery about the cold. Now heat, on the other hand, and kiln dried, a kiln gets very hot, above 145, 150 degrees. Anything above 120 degrees will kill a yeast spore.
Okay.
So I'm
good to know. Yeah.
I'm good with the risk. Your lungs are a perfect incubator.
Yeah.
But I'm going to argue with the cold being a cure or air dry. I believe that we're not killing the spores that way, but I'll do some research and get back to you all on that.
Yeah, it's a good thing to pass on.
Yeah, Gene, I agree with you, Gene. I don't think that the air drying is just putting it in suspended animation. So I think that temperature aspect through a kiln dry and over time, that's what's really going to do it. I know that if it is not fed and it doesn't have a way of re-incubating, that can be a process. But it'll be interesting to see what you find out. That'd be great.
Yep.
Yeah, I will just add one more thing, and that is I did not use that cherry wood for over 2 years, so it went through a couple of winters. So fortunately, I think I'm okay.
If I could butt in here, I spent my whole career working with microbes, and one of the best ways to preserve them is to put them in ultra low temperatures. You can keep them forever that way, and some fungal spores especially are amazingly resistant even to heat. And so it's a problem, for example, with space probes, that no one wants to contaminate Mars or the moon or something like that with Earth microbes. It's really hard to come up with a method that actually would get them all. Heat is one of the best, but even at the temperatures of a kiln, you have to put it in that kiln for a long time to get them all. And it varies greatly between strains. I mean, there are literally billions of strains of funguses and also prokaryotes. And the spectrum of resistance across these things is amazing. Maybe people have heard of vent organisms that have been isolated from the deep sea vents in the ocean. Some of those things metabolize. They're living creatures that live at temperatures above the temperature of boiling water.
Yeah, and not only that, but the immense power, or the immense pressure of all that water too. So, these fungus and bacteria have been around for a lot longer than we have, and ultimately they're the ones that put us back into compost. So, but yeah, it's a very interesting conversation. But I think that it is to always err on caution when you're around these small particles, that you really want to make sure that you're protected that way. Definitely.
So Bob, I've got a question for you while you're still on, regarding spores and so forth. I think the one thing that can kind of help us all is that we know from the COVID virus that N95 masks are pretty effective. Sealing questions aside, what would you tell us about filtration and the effect of and the size of the average fungal particle that we might have to worry about?
Here's the thing to remember about N95 masks. They are completely incapable of filtering viruses by themselves. The thing that makes them work, and this would be true for most spores and things like that as well, is that these very tiny particles, nanometer-sized particles, they stick to things. And in particular, they stick to fluid particles like aerosols and other dust particles and things like that. those particles, the vast majority of them are greater in size than an N95 pore size, and that's why the N95 works. In my work, we did all our work in under HEPA filtration. HEPA filtration is also much smaller than N95, but it can't stop a virus, but it does because viruses don't float around on their own in the air. They attach to things. And so that's what makes that stuff work.
So a fungal spore or particle is attached to something that attaches to the filter.
Most likely that is what will happen. And you know, it's, for example, let me give you another example. This fine dust you're seeing after you're sanding, that's stuff that's getting through the filter in that vacuum system you've got. And I've noticed that myself in my shop. And that is really fine stuff, but it probably won't go through an N95 mask. And so when you put your mask, especially when you put that 3M mask on that's got the canisters on the side, that's what I use. Those are highly, highly effective. But for all this stuff, it's all these things are statistical. You know, some of those things are going to get through. Even the best filters are not absolute. You just can't make them absolute. So the standards are all set up so that you get you get 3 or 4 or 5 logs of removal. You know, only 1 in a billion can get through. That's good enough for public health stuff, because you've got all these other things in place as well. The likelihood that something will even get to your mask is pretty low, and the likelihood that it'll get through is lower yet. And you just stack all these things together, and that's what creates public safety. But every once in a while, you know, 1 in a million or 1 in 10 million people comes down with something. It's because statistically that could happen.
So kind of taking this to where it really matters, you wear a mask, N95 paper mask with that loose fit, or the cup mask that has a tight fit around your face, like you said you wear. I saw that Fred was showing. I have one of those. For the infinitesimally small particles or percent of particles that get into my lungs, theoretically, the mucosa lining and the alveoli and the little hairs that are pumping everything out, I should be able to, you know, and again, statistically speaking, I'm likely to survive. My body can process those tiny amount of items compared to a big caseload. I don't wear a mask. I'm in a closed room and I'm sanding like crazy, coughing up boogers and, you know, the whole thing. I'm more at risk in that latter case than if I wear a mask.
Gene, it's the difference between taking in billions and billions of those particles and taking in maybe 1 or 2 or maybe none. Okay. So it's a huge difference. And I think you really can put your trust in the regulatory system, which establishes what can be called an N95 mask and what it can do. And when you especially if you look at the 3M literature that comes with the you know, the plastic one with the wings on it, and that kind of thing, and also just for the paper masks, there'll be a specification that they meet, and that specification will tell you exactly what that filter can do. You can, as you point out, though, you can completely corrupt the thing by just you know, leaving big gaps. You're not supposed to have a beard. I will say I've had a beard my whole career, and I don't know that I've caught anything, but it's so, you know, you can get by even if it's not perfect, but yeah, I think as long as you do the other thing that works great for COVID-19 is distancing. I mean, really, it doesn't survive long in a passage from me to you. 6 feet's enough for it to settle out of the range of, the excreted particles that we all make when we talk and breathe even. So, yeah, and it has worked. People, we're still afflicted by this thing, but believe me, if we weren't social distancing, if we weren't using these masks, we'd be looking a lot more like India.
Unfortunately for them.
One final footnote. I wear an N95 when I go to my ophthalmologist, and he looks at me and says, "You're fogging up." And I make that thing as tight as I can. And then he puts a strip of adhesive over, not to prevent, viral transmission.
He wants to see your eyes.
So he wants to see my eyes.
I was just the ophthalmologist this week. I just had my eye lasered on this side, but it was he did the same thing, tape down the mask to keep the fog. I feel like doing it anyway. I hate that when my glasses fog up. But in the shop, that's another reason why I wear the 3M mask, because it fits tight enough around my nose that it doesn't fog my glasses. I can still see.
Exactly.
Yeah. It's also it's a much more comfortable thing to wear because it has a valve in it, so you're not constantly rebreathing the same air, and the filters are much higher capacity, that kind of thing. They're nice.
Well, I apologize for hijacking your session, Fred, going down the path of dust particles, but I think that was a good spot. And I'm going to, when I do the video editing, I'm actually going to separate the conversation about dust and so forth from the main body of your presentation, just because I think it's an important topic. Bob, thank you for piping up, and I had forgotten that you were on the call. I saw you come in, but I had forgotten that you were on, or I would have asked you directly. So thank you for piping up.